Hey guys, welcome back to the show. Today I'm here with Ben Jawdat of Revterra. Ben and I have known each other for a very long time, and I've had the benefit of seeing his journey. Revterra fundamentally is a flywheel business, but it's not like any flywheel business we've ever seen before. So I'd love, Ben, for you to tell us about what you guys are doing at Revterra.
Sure. Yeah. Thank you, Jason. Essentially, we're developing a modular energy storage system.
Mm-hmm.
So as you mentioned, we're leveraging an off-the-shelf existing technology, which is flywheel-based energy storage. So essentially, you're spinning up a large steel disk to high speeds to store energy, and then slowing it down to discharge. And we are specifically using this in the context of high-power electric vehicle charging.
Mm-hmm.
And what we're doing differently than previous flywheel energy storage companies is primarily related to the bearing technology.
Mm-hmm.
So one of the limitations with flywheels historically is the very low efficiency. And then there's some other limitations that I can get into later. But essentially, we are eliminating that particular obstacle with our bearing technology and making it so that flywheels can store energy just as efficiently as lithium-ion batteries. Then we can leverage all of the inherent benefits of flywheel energy storage, which is long cycle life, high power density, and non-toxic byproducts. So you can make it out of recycled steel. You can recycle it at the end of the lifespan of the system. So it has a pretty low environmental impact.
Mm-hmm. And that would be compared to like batteries in the same application. So you mentioned like there's a cycle life difference. Like talk to me a little bit about some of the challenges we're seeing with current battery technology where maybe this is a better fit.
Yeah, I mean, so it depends on the application. I think electrochemical batteries are a really good fit, obviously, for mobile applications like electric vehicles, high energy density. And you're not cycling it all the time. So you're cycling it maybe once every couple of days.
That's like a charge discharge.
Yeah, charge discharge is one cycle. So if you charge your car once every few days, the battery's going to last a very long time. If you have 7,000 cycles. But if you try now to use it in an application where you have to cycle it, charge and discharge 5 or 10 or 15 times per day, then you run into issues with the lifespan. And you may have to replace that battery a lot more frequently than you would in an application like mobile application. And so that's where it fits into electric vehicle charging specifically. And there's a couple of other applications that I can talk about, but essentially you have a battery that's stationary at the EV charging station that's charging the battery on the car. So that battery that's stationary at the charging station has to cycle multiple times per day. And so that's an area where we see some limitations with electrochemical batteries, some pretty strong limitations that we're trying to overcome with an electromechanical solution.
Yeah. One of the things I've heard that's different about the charging infrastructure is like with the, I guess, gas stations today, the current way we fill up and charge our cars, right? Like if you think about it that way, there's something like 20-to-1 gas stations per car or something like that, right? And you're looking at me like my number is like wrong.
You said 20 gas stations
20 cars per
20
cars per gas station in America.
Yeah.
And kind of the prediction is you're going to have like almost a 1-to-1 ratio of cars to charging stations in the future, in part because the charging takes longer, and in part because maybe you have a charging station at home. But like I guess the way to describe it is like the duty cycle almost on EV charging is different, because when you go to a gas station today, it's a bad experience if you have to wait in line or if you have to spend more than 3 minutes kind of getting your car filled up. If you're constantly like having cars lined up to use an EV charging station, like what kind of problems does that present for a charger, I guess?
Well, yeah. So I mean, there's kind of backing up a little bit. So you have low power chargers, which people have at home.
Okay.
And those are relatively inexpensive. And if you have, a garage, then you can charge your car overnight. That's probably the most efficient way for that scenario. And then if you're taking a road trip or you're driving a significant distance or you don't have a garage where you can park your car and charge, then you're probably going to have to charge your car somewhere else.
Mm-hmm.
And in that scenario, you probably want a fast charger.
Mm-hmm.
There may be cases where you could charge at work or something like that. But if you're on the go, then you would want a fast charger. And there's different levels of fast charging.
Okay.
So there's level 2, level 3. Level 3 can go range anywhere from 50 kilowatts to 350 kilowatts.
Mm-hmm.
And 350 kilowatts is, quite a bit of power. If you had 8 of those running at the same time, you'd be consuming about as much power as a 1 million square foot building does. So, it requires some infrastructure upgrades. And there's basically 2 ways to do it. Either you upgrade the infrastructure, so you get the utility company involved, you bring in additional distribution lines to supply, let's say you had 10 DC fast chargers, that would be 3.5 megawatts of power. And in that case, you could essentially charge cars back to back. But in most cases, the penetration of electric vehicles is not that high. So you wouldn't have, at most charging stations, cars continuously coming back to back. Especially, let's say you're driving from Houston to Austin and you want to stop for a charge. There's not going to be a continuous, most likely, line of cars fast charging just because of the number of EVs on the road right now. So in a lot of cases, it would make more sense to have some kind of a buffer. So you don't actually spend that time and money to upgrade the infrastructure and bring in additional power lines, distribution lines. You would simply put an energy storage system, and that energy storage system would slowly charge from whatever connection you have on site. And then it would discharge really quickly at high power to the EV charger. So you would enable that fast charging. And you could probably charge, and with our system, you could charge 2 to 3 cars back to back, depending on the size of the batteries and the number of modules there. But those are kind of the range of options.
Okay. So in many ways, the driver for this is because people don't want to put in the big honking transmission line and whatever substation you need for, did I hear you say like 3.5 megawatts?
For 10,
if you had to do 10.
Chargers,
Yeah.
So it's an infrastructure bottleneck, really.
Okay.
And another way to think about it is if you have like a water faucet or something, and you wanted to have, a high flow rate with that water, you'd have to bring in an additional pipeline to supply that water. Instead of bringing in the pipeline, if you only need that high flow rate once in a while, you can just put a water tank at the site. That water tank can accumulate from the very low flow rate water, and then you could dump it really quickly whenever you need it. So that's the analogy.
I think I had that slide in my pitch deck at one point.
Oh, really?
Because I was doing hybrid power, and it was the same thing for our gas turbine, because we needed to dump power really quick. And, and we went with ultra caps, right? Because we went with short discharge. We were dealing with like 6-second cycles. So for us, in our application, it made a lot of sense. And we were trying to deal with the fact that the gas turbine took half a minute to get where it needed to go in terms of running effectively. And ours was on a fully remote system, or a fully disconnected system. So all the like power management had to be done within our gas turbine unit. But literally had like a bathtub in our slide deck.
Okay. Yeah.
Filling and discharging.
Yeah. Generally understand the water.
The water analogy. Yeah. Good. And how did you, you said you were working on the bearing technology, and that's kind of the AHA technology. Where did that technology come from?
So it is related to some of the work that I was doing in grad school. So I was studying new superconducting materials during my PhD. And one of the core components of the bearing is high temperature superconducting materials. So tangentially related to the work I was doing in grad school. And I developed it around that time and received, got some IP on it later, a few years later, and then was thinking about commercializing the bearing itself, the magnetic bearing technology itself, but was really interested in energy storage and trying to enable a clean enabler of renewable power and electrification. So kinetic energy storage was just has a lot of inherent benefits. And I thought with the magnetic bearing, we could overcome some of those limitations.
Mm-hmm. Mm-hmm. And you said a keyword there. It's a high temperature superconductor. It's not. Let's break down what that actually means.
Yeah. So a superconductor is a material that can conduct electricity with no resistance. So normally metals like copper, you can use them to conduct electricity, but they have resistance because the electrons are bouncing around. In a superconductor, when you cool them below a certain temperature, the electrons pair up together and they move through the material without bumping into the other atoms there. So it has some other interesting properties like trapping magnetic fields. And that trapping magnetic fields part of the equation is what we're leveraging in our system with the magnetic levitation. And high temperature is a relative term. So it's liquid nitrogen temperatures, but it's relative to liquid helium temperatures, which other superconductors had operated before the discovery of the high temperature superconductor. So that's why they're called high temperature relative to the very low temperature.
And from like a cost basis, it's easier to get liquid nitrogen, or we know how to produce it even, right? As opposed to helium. I don't even know where I would get liquid helium.
Yeah, liquid helium is generally a byproduct of some other manufacturing processes, and it's relatively limited quantity for research purposes. And several years ago, there was kind of a shortage of liquid helium, so a lot of research labs were affected by that and tried to switch to what are called cryogen-free systems. So, but just to be clear, our system doesn't actually use liquid nitrogen. It uses something called a cryo cooler. So it is a pretty simple electromechanical device, basically, a linear motor accelerating a piston back and forth at 60 hertz and pushing a gas across a heat exchanger to generate a temperature gradient. So we're using that because it's obviously more suitable for a commercial device than liquid nitrogen.
Gotcha.
But in a lab, typically people might use liquid nitrogen because it's just very easy and cheap to come by.
Yeah, but I guess it's in a temperature regime where we know how to manage it. We know how to create it with the cryo cooler.
Yeah, liquid nitrogen temperatures are pretty accessible.
Okay, and that's kind of what enables this to happen now in terms of the technology barriers. And when we think about the product itself, like you're making a flywheel, we know you're addressing this kind of edge challenge with the grid to support EV infrastructure. Who buys the actual product, and what is the product they're looking at buying today when you think about bringing this to market?
So there's a few different potential customers here in the market. So one type of customer would be a private company that's developing a high power EV fast charging network. And that company might also have the hardware or be a hardware developer of the actual fast charging hardware, but not have the energy storage part of it, and want to mitigate or reduce their time to install the chargers and their infrastructure costs. And it kind of depends if they're going to own and operate the charger themselves, or if they're going to sell it to somebody else. So whoever's ultimately paying for that cost of installing and upgrading that infrastructure would probably be the customer. So yeah, EV fast charging network developers, and that could also be utility companies. So there's some utility companies that are actually developing fast charging networks, or they offer it to some commercial industrial customers as part of their offering. So those are a couple of potential customers in the EV charging space that we've been talking to. And then there's other applications beyond electric vehicle charging that we've been looking at. And one of the most notable ones is backup power for commercial and industrial settings. So as we progress along this trend of electrifying everything, the power quality issue becomes more notable. And it's pretty critical to have clean, continuous uninterrupted power for a lot of these commercial industrial companies that have a lot of electrified processes, whether it's semiconductor manufacturers, plastic manufacturers, data centers. All of these types of customers are, potentially having issues with small voltage drops or very short power outages. So because of the high power to energy ratio, our system is pretty suitable for that application as well.
Yeah, and so like a voltage drop is like when we talk about power quality, a voltage drop is when it goes below 120 or the frequency changes, and that's just bad for equipment that expects to be receiving like a 120 volt or 60 hertz, right?
Yeah, so there would be a range of different types of equipment and what that equipment can tolerate. So some equipment, like a large rotating piece of machinery that has like an induction motor on it or something, probably could tolerate a little bit of a voltage drop or a small frequency drop. But there's other more sensitive pieces of equipment that could not tolerate that. And whether it's because the equipment itself would be damaged or because the process that it's running would be interrupted. And a lot of times it's that the process would be interrupted. And an example of that, like the plastic manufacturing, if you have a very short power interruption, you could basically damage or deform the plastic parts that are being generated. So you have to throw that away and then start over again. So there's a lot of examples like that where the process is interrupted and then it takes, like a half day or a day to get things running again, or even a few hours, but that's a lot of time and expense.
Yeah. So a 5 or 10 second power interruption can cost like a whole day of work. Is why that's a big deal. Interesting. And so it sounds like part of the reason why the time is now to bring this kind of technology to market is the compounding of like EV infrastructure changing over, but also just the electrification of everything.
Yes.
And the increasing sophistication of the kind of the grid companies to even put products at the edge of the grid.
Yes, yeah. I would agree with that. I think electrification in mobility and elsewhere is that coupled with our existing electric grid infrastructure, which is designed around, the developments in the earlier, 20th century with primarily designed around alternating current generation and loads that, as we're progressing, there seems to be a highlight in deficiencies, whether it's infrastructure bottlenecks, which we're trying to solve with the electric vehicle charging, but also reliability and stability overall. So, just to briefly mention another application of our technology, when you get to really high penetration of renewables on the electric grid or any grid, for example, and Europe is dealing with this more than we are at the moment because in some countries like the UK and Germany, they've progressed to relatively high penetration of renewables. But solar power, for example, produces DC power. Conventional generators produce AC. And with conventional generators, not only do they produce AC power, but they have a physical inertia to them. So you have these large rotors that are spinning at 60 hertz, producing power. And because of that, if one of those generators goes offline, the others continue to prevent the frequency from dropping because of that inertia. It's basically a flywheel effect. In fact, they are basically acting as flywheels in that case. When we go to solar power with DC, that's called an asynchronous power supply. So they don't have that inertia aspect to them, although you can synthetically generate it with lithium ion batteries or other electrochemical energy storage with a virtual intermediary. It requires a lot of power electronics. Kind of unclear how it works at 100% renewables penetration. So basically when you get to higher renewables penetration, you have this issue with grid stability. So one of the things that we're really interested in is potentially enabling fully renewables powered grids with the same type of stability and inertia that has existed in conventional grids. Because, the stability of our electric grid is ultimately probably one of the most important things in our society.
Yeah. I guess one of the things I remember, this is me pretending to remember electrical engineering. Yeah, you have your rotating mass, and that creates your little frequency at your 60 hertz. And I remember we started to hook up an inverter system, and that would also generate like 60 hertz. And I kept and it was a load following kind of inverter, and I would look at it, and it would kind of need a reference signal to know what to be at.
Right.
And if it didn't have the reference signal, it would just kind of fall over and go, I don't know what the frequency is. No power.
Yeah, those are grid following.
Yeah, exactly. That's what I had.
Also a grid forming.
I had a grid following system, and like those two are not always compatible. Like it kind of needs. It's got to decide if it's going to be the grid or it's got to decide if it's following.
Exactly.
And the question I think you're getting to is like, if we become 100% renewable, who's still setting the tone or who's setting the frequency and making sure that it's at that 60 hertz in some ways.
Yeah, I mean,
that's an oversimplification.
That's
like
part
a very
of it.
gross oversimplification.
That's part of it.
Yeah, interesting. So I think you were were you born and raised here in Houston? I know you went to school. Like you're like a triple threat in Houston from an education standpoint.
In New Orleans.
Okay. Yeah.
And moved here when I was 1.
Okay.
So
we'll
pretty much, I guess you could say I'm from Houston. And then, I, except for undergrad, which I did in Atlanta, I did, high school and grad school in Houston and all that. And then, postdoc in New Mexico and then back in Houston to start the company.
What did you always know you'd be an entrepreneur?
No.
Yeah.
Actually, that is, I think secretly, I wanted to be an entrepreneur. But in a way, I think PhD program is kind of an entrepreneurship type of experience. So I guess what I mean is I didn't realize it at the time, secretly. I didn't realize it at the time, but that was my main interest, is developing something new from scratch and seeing it into development. In the lab, you don't quite see something into a commercial product, but you kind of do the first half of it, which is you find a fundamental problem and you come up with a solution to it, or you research the problem and you solve it to some degree, and you push the boundary of knowledge a little bit. But some of the skills are quite transferable. So the grant writing, research proposals, you essentially have to pitch to your thesis committee, funding agencies, and all of that. I really enjoyed that aspect of it. And once I kind of heard about or realized this whole thing about entrepreneurship, which I didn't really know a lot about during grad school, it seemed really exciting.
And I think here in Houston, like a lot of your peers who are in grad school have chosen not to make that leap, or they haven't seen that path. Is that a knowledge question? Like, it seems like you were introduced to entrepreneurship as a path and you said, oh, I could do this. Right? When did that?
I don't think I was, actually, because a lot of times, and I think this is probably a little bit different now, there does seem to be more, and I see schools like Rice, for example, have programs specifically to try to give exposure to grad students to entrepreneurship, and maybe even fund some students to start companies and all that. For me, I didn't necessarily know about that, but I kind of stumbled across it during the development of some IP around the bearing technology. But I would say, to the extent possible, having that knowledge would at least give people the choice to pursue this or that. And having some kind of funding opportunity helps a lot. With the STTR programs in particular, I think are extremely beneficial, because if you're a grad student, you can actually submit an STTR proposal with your PI, your professor. You can still be a grad student, and then, if it seems very promising, then you can potentially spin it off as a company. But Yeah.
Did you guys do an STTR?
I did not. No,
Yeah.
I did not do an STTR in grad school. I went and did a postdoc in a completely different field.
Yeah.
And then came back to it.
Where would a student learn about? I guess they just got to Google STTR these days, or
yeah, I mean, so STTR, SBIR, it's called the Small Business Innovative Research Program.
Mm-hmm.
So it is funded by the United States government, and it provides non-dilutive grant funding for, I think, American-based companies. I'm not sure if you have to be. I don't think you have to be a citizen, but
I think you have
to be based in the U.S.
and majority owned by U.S. I think is the other thing.
Yeah. And that program there's basically the government funds that, gives various departments funding to do that. So the National Science Foundation is one. That's where I got funding for Revterra. But there's Department of Defense, Army, Navy, Air Force. There's ARPA-E, there's DOE, all of these agencies, NASA, have funding to provide these SBIR programs. And really anybody can submit a proposal if you put together a team. If you don't have somebody technical on your team, then it's probably a good idea to pair up with a university. If you've seen a patent or something that they have, and you want to try to transition it to a real world application, that's a pretty good way to do it.
Gotcha. And when you decided to start a company, you decided to stay here in Houston.
Yes. Well, yeah, pretty much. Because I was in New Mexico for my postdoc, and then I did a postdoc at Rice. And around that time was when I started thinking about starting the company. And I thought, so I was in Houston, but Houston just seemed like the perfect place for an energy transition company that's building really large hardware.
Yeah.
Because of the existing infrastructure here with the oil and gas industry. Yeah.
So tell us a little more about kind of the resources you see here in Houston that helped you make that decision.
Right. So I guess you could split that into kind of like startup resources and manufacturing resources. I think from the manufacturing point of view, there's a ton of machine shops, engineers, mechanical engineers, machinists, all of that. So from the point of view of actually building the hardware and having the know-how around here to deal with that, then there's plenty of that here in Houston. From the startup ecosystem point of view, I think when I started the company, there was a few options around here. So there was Houston Technology Center. Then that became Houston Exponential, and there was Station Houston, and I think that was basically it around that time.
We probably met at Houston Technology Center.
No? Yes, I think we met at Houston Technology Center, and then we also met at Station Houston, having like a preliminary early stage energy bar brainstorming session.
Yep.
But yeah, I think now there's obviously more resources, but I think at the time there were a couple of options, and through Houston Technology Center, I got like a $25K investment from the McNair Foundation, and that allowed me to build a small benchtop demo system and progress it from there.
Did not realize that's where that benchtop unit came from. It's funny how you got to piece together the different funding sources to kind of move the technical ball forward.
Yes. Yeah, exactly.
Interesting. I recall in the early days, you were renting space from a church to build this thing.
So
right?
I was renting. I was renting space from a place called Fruition Technology Labs, and they moved to another building in North Houston, and to join up with another accelerator that was forming up there. That building, that accelerator kind of left. So the building was then purchased by the church, but they were very friendly landlords, and they were very flexible. So I had essentially a lab on the second or third floor, and there were some AC issues at the time, but I think it was all fine. And I was able to build up the demo.
Yeah.
That was actually that I got NSF funding and built the 1 kilowatt prototype there too.
Interesting. One of the things that is fun sometimes is like that there are pitch events around town that like just didn't used to happen before. And so like these guys at Digital Wildcatters hosted one at the Heights like 2 weeks ago, and I saw a bunch of entrepreneurs I had met previously, but like that's not something that existed very consistently previously, and I think it kind of speaks to a vibrant and growing ecosystem here, and I think it kind of shows that the innovation community is evolving where maybe it wasn't before. And so like what maybe one of these hidden gems was like that prize program that you got that first investment from. Is that still something that people should apply to? Or?
That no longer exists.
Yeah, so that was attached to HTC.
That was kind of attached to HTC.
Yeah.
So yeah, I mean, I think we don't have that many programs like that in Houston. I think there's maybe one at the moment, but having more programs where it's an accelerator, but you get some type of investment into the company as part of the accelerator, I think can be pretty helpful. It's kind of like the Y Combinator model where it sets some kind of evaluation on your company. You get some seed funding to maybe work on the company full-time or at least part-time and build that initial thing, proof of concept, demo, maybe it's an app, whatever it is. And if it's you, or it gives you the resources to like bring somebody else on board. But I think that first stage is pretty hard for a lot of people, myself included. It's like getting across that gap.
Yeah. And so that kind of points to gaps in our ecosystem. So it sounds like having more like accelerator plus prize programs is one where like there needs to be something put in there.
Yeah, I wouldn't even call it a prize. It's kind of like an investment. So, and so the accelerator gets skin in the game, and the entrepreneur gets some seed funding. It attracts even more, I would say, entrepreneurs, high caliber entrepreneurs to apply for those types of programs. But obviously, it requires more funding on the accelerator side to be able to do that. But that is one thing that I think Houston could benefit a lot from.
Yeah, like an accelerator. Yeah. When you think about getting technology to market, do you have a sense of how things like the Inflation Reduction Act is like driving like demand from strategic partners for you guys?
Yeah, I mean, I think there's a lot of movement because of that Inflation Reduction Act. It's definitely like a full-time role to understand it and implement, develop towards taking advantage of the Inflation Reduction Act. And a lot of it is also, geared towards companies that have like a commercially available product and all that. But definitely there's a lot of additional interest in the space because of the Inflation Reduction Act, just generally speaking. And that I think has helped us as well.
Yeah. And does that influence the way you think about building product, or is that something where you're going to tackle it in the future?
Not really. Yeah. I think you should develop a technology or a product to be able to kind of compete or be successful without the incentives. So, it definitely helps to have that, but I think you should always try to, develop something that can compete with the landscape without those incentives.
Yeah. Yeah. So that, there's incentives for deployment. Like, are there other things that government or policy people should be thinking about if we wanted to accelerate innovation, especially when you think about your own journey through?
Yeah. I mean, I think I mentioned this a little bit, but the valley of death is pretty difficult for entrepreneurs and for transitioning technologies whether it's like from small scale to large scale or lab to
Yeah.
commercial.
So tell us about what you mean by the valley of death. Like it.
Oh, yeah. Valley of death is essentially you have a technology or product that is demonstrated as a proof of concept, and it's lab scale or benchtop scale. So you've proven it at that scale. You have, some kind of product market fit probably, but you don't have a commercial size system and you don't have a pilot test yet. So you haven't proven it in a relevant context. In order to get there, you have to build up your technology and scale it up. And in order to do that, usually you need some substantial amount of funding. And so that's what the Valley of Death is, basically getting from the smaller scale proof of concept to a commercial pilot and commercialization of your technology. And to some extent, like the SBIR, SCTR can help with that, but oftentimes you may need even a little bit more funding than that to really get it to the point where you can deploy it into the hands of a customer. So, and that's where sometimes I think entrepreneurs can get stuck, because if you want to raise funding as well, typically you need to have that commercial traction. So
yeah, I think like an SBIR today is like what, $225,000 maybe to start.
I think they increased it to 275.
Oh man,
yeah.
I started a company at the wrong
Saw
time.
That recently, yeah.
And then there's like a multi-phase program. So in the second phase, you can get like over like 36 months. It's like $1.5 million, depending on the program. And so kind of, even though that sounds like a lot of money when you're developing hard tech, that goes quick, right? And so in some ways, the question is there a way to take that existing program and put more capital in? And what we're hearing is that, especially at phase one, they're continuing to increase the amount of capital available.
It seems like that they're doing that. And it is agency specific as well. So I think NSF offers the most for a phase one relative to others.
Yeah. Tell me a little bit about the team at Revterra.
Right now, we have 5 full-time people, as well as a part-time intern. And the breakdown of those 5 people, so it's myself, Patrick, who's our CFO, joined me in 2021. So a couple of years now, just at the beginning of the Series A fundraise. And post Series A, we hired 3 engineers, full-time engineers, electrical engineer, and 2 mechanical engineers. And so yeah, basically have like 4 people on the technical team, and Patrick as a CFO in the company. And I think the team so far is working really well together. And obviously we have a lot more bandwidth and to develop this commercial scale system than we did several months ago. We might hire another 1 to 2 engineers over the coming few months. So we're looking around for additional mechanical engineers. Yeah.
How did you find Patrick? Because I feel like you guys were fundraising together, and he's such a gem.
Yes, Patrick is awesome. So we met through a mutual friend that we have both known, for a very long time. And I was talking to this friend about, I'm looking to hire, to bring somebody on board to help with the fundraise. And he was like, hey, I know this guy, is at Rice. And so we connected and started chatting, and Patrick, was pretty interested in what I was doing. So decided to join the effort. And I think we've worked pretty well together, and he's added tremendously to the team. So
yeah, he's he's a trooper, because he jumped in with like 2 feet and did all the accelerators with you.
Yes,
right?
Yeah, Oh, just on
what accelerators did you guys end up doing together?
Well, we did 2 actually accelerators last year. One of them is still ongoing. So one was Black & Veatch. Had an accelerator program called Ignite X.
Tell me about Black & Veatch, because I don't know them as a brand.
Yeah, so Black & Veatch is a large EPC, engineering, procurement, construction firm. And they have a lot of experience historically in electric infrastructure, power infrastructure projects, large projects. And they did a lot of work with Tesla on the superchargers as well. And so that was really exciting because we got to, participate and learn from the EPC on what to kind of better our understanding of what our installations might look like. And we have kind of an ongoing relationship with them even after the accelerator has ended. And then the other accelerator is the 35 Mules accelerator program. So 35 Mules is an accelerator hosted by Florida Power and Light, NextEra. So Florida Power and Light is part of NextEra utility company. It's a regulated utility based in Florida, and they have this accelerator program where it's on site. So it's a full-time, at least one person has to be full-time on site. And you get to basically be connected with folks in various departments within NextEra. And you get to test your value proposition with engineers, business development people. Basically, they find who you need to talk to within the utility company. And they work really hard to make those connections and follow-up meetings. And you also get $100K in non-dilutive grant funding, which is critically helpful for companies. So I would say that's probably those two programs were very impactful.
So something that's changed since when I was doing my business is like that these corporate accelerators exist where there is a non-dilutive component, but in some ways the acceleration is not to accelerate the business so you can pitch and raise money from angels. The accelerator is so you can get to a product market fit internally, and they kind of have an advanced seat at the table with making sure their needs are met. Is that a fair statement?
On the corporate-based accelerator programs? I mean, I would say that's fair. Like they would like to have, be the first to, I guess, be part of these new technologies, and it's mutually beneficial.
Yeah,
so
of course
they get exposure. The company gets exposure to these, I guess, cutting edge new technologies, new products, and as a startup, you obviously get access to this large, mature company that can help, further your product market fit at an early stage.
Yeah, that's fantastic. Well, unfortunately, we're running low on time. Tell us about something that our audience here could do to help support you as you think about the next 12 months at Revterra.
Sure. So a couple things. I mean, one is we are, as I mentioned before, we're looking to hire a couple of mechanical engineers. So if you're a mechanical engineer, have some experience there, and you're interested in working with an early stage startup, and you have some experience in early stage product design, mechanical engineering design, then take a look at our website.
And what's the website?
It's www.revterra.io.
Okay. I'll put that in the show notes.
Okay.
And how should people look you up? Should they find you on LinkedIn?
LinkedIn, I suppose, is the most, the easiest way to do that.
Cool. All right. Is there any parting thoughts you want to leave the audience with, like words of wisdom?
Words of wisdom. Put me on a spot with that one. I think, I think just generally speaking, for anybody considering starting a company or entrepreneurship, one of the most challenging parts is that first step of it. And my advice on that is just focus on building something, something that can demonstrate, not necessarily like you have to build the final product or anything. Just focus on building something that demonstrates your your technical know-how, even if it's not engineering, but your expertise in the field, and something that you can show to potential partners, whether it's funding agencies, investors, et cetera. But it's just building that first thing, whether it's, a demo or a proof of concept, that once you get there, it gets easier to progress the company.
Cool. Well, thanks, Ben.